Hi, I am Professor D.K. Panda from Ohio State University. Together with my colleagues Amar Awan and Dr. Hari Subramani, we have an exciting tutorial coming up for the Supercomputing 2019. This tutorial is titled High Performance Distributed Deep Learning, a Beginner's Guide. So in this short video, I'd like to introduce the overview of this tutorial and how it can help you to understand more about distributed deep learning. As many of you know, the deep learning is emerging as a big field these days. Of course, it is a part of the bigger field of the artificial intelligence or AI. Also, it is a subset of the machine learning or the ML. Now, many of these concepts are now trying to be used in real life applications, like let's say, for example, here capture generation, generating images, style transfer, translation of text. A lot of new kinds of applications are coming up to take advantage of the deep learning. Of course, the deep learning and the machine learning, the AI, many of these concepts have been there in the field for many years, but nowadays there is a lot of renewed interest, especially for the deep learning, and of course, there is also a lot of hype. Now, the key success has been the deep neural networks, and these deep neural networks or DNNs were there in the late 80s, but they were not able to be computable. That means if you have a very large network, you cannot actually compute it on a realistic time frame to make sure that the model works. And that's what changed over the recent years, especially in the multi-core, many-core era, especially with the advantage of GPUs, which is at the core of the DNN training these days. Now, significant achievements have taken place over the years. For example, here if you see on a 2 DGX 580, it was trying to take almost like 8,000 plus minutes, and nowadays you can do it on a DGX2 almost with a 500x fold improvement in 5 years. Of course, the CPUs are also trying to catch up very fast, and at the same time, we have availability of data sets like MNIST, CFAR, ImageNet. A lot of these data sets are helping people to validate their models and also their frameworks. And at the same time, we are also seeing with the overall systems, people are able to get very excellent accuracy for many of these application areas. Things in perspective, now of course the community has a lot of questions saying how to scale out the deep learning or the DL workloads on HPC systems. You might have these kind of questions in your mind saying, can we understand DNN training performance in a holistic way? How to correlate low-level performance to high-level metrics? What are the new design challenges brought forward by DL frameworks for communication runtimes? Can we redesign MPI runtimes for these new requirements? How to co-design MPI runtimes and DL frameworks like Caffe? And also how to handle out-of-code DNN trainings on GPUs. Because these days in the GPUs, as the model sizes are increasing, it's increasingly becoming difficult to put the entire model inside the one of the GPUs. So how to handle these kind of scenarios? And then broadly, the questions are what are the open issues at the intersection of DL and HPC? Now, the broad challenge the community is heading into at the intersection of the deep learning and HPC is to get the both scale up as well as scale out. So the scale up in terms of using more and more number of GPUs within a node and getting very good performance. These are being helped by some of the libraries like cuDNN, Intel MKL DNN, etc. Now for the scale out, there are a lot of different kinds of solutions are being proposed, starting with NVIDIA's Nickel 2 to MPI-based solutions to the TensorFlow gRPC-based solutions as well as the traditional Hadoop-based solutions. Of course, the community wants to go into this extreme right corner to get the best scale up and best scale up. In order to understand all these issues, we have put together an excellent tutorial. The outline is as follows. We'll start with a brief introduction of the past, present, and future of deep learning, trying to expose you to the concepts of deep neural networks, give you an overview of the diverse applications of deep learning, as well as the different kinds of deep learning frameworks like TensorFlow, PyTorch. Those are available recently. And then we'll try to take an overview of the execution environments, how these different kinds of frameworks actually get run on the parallel systems, what are the kind of the issues, and this is where we will go into depth of the challenges being faced by parallel and distributed DNN training. And then we'll also take a look at the latest trends in HPC technologies, especially with respect to computing, the acceleration technology, the storage, and the networking. And then we'll try to put all these things together to understand the challenges in exploiting HPC technologies for deep learning. And once you understand the challenges, we'll try to provide you a set of solutions and case studies to illustrate to you how the community is currently trying to solve many of these issues. And then we'll try to also discuss some of the open issues and challenges the community is facing these days. And we'll be finishing this tutorial with a set of very nice hands-on exercises. And these exercises will actually help attendees to get a very good experience with multi-node DNN training using TensorFlow, which is a very common framework. And they will also try to get an understanding about the impact of optimized MPI designs for DL workloads when run on the HPC systems. And we'll take the attendees through a very systematic way of benchmarking different kinds of environments with the same DL framework like a TensorFlow. For example, we'll start with benchmarking TensorFlow on a single GPU, then we'll try to move into multiple GPUs using Nickel 2, then multiple GPUs using an MPI library like a MapIS2 GDR, and then let the attendees get a feel for how these kind of the underlying communication runtimes actually have impact on the overall performance of the DL applications. So this tutorial will be held on Sunday, November 17th from 8:30 a.m. to 12 p.m. in room 207. And this URL provides more information on this tutorial. And I hope a lot of you will be very interested in attending this tutorial and getting a very broad understanding of where this high performance distributed deep learning field is heading. If you have any questions before the conference, please feel free to send an email to me as well as my colleagues, and we'll be very happy to answer these questions. And we look forward to seeing many of you at the conference, and especially on this tutorial. See you then. Thank you.